The second part of that story is the uptake of CO2, okay, by the oceans. So in overall, on these relatively short timescales, the ocean actually operates as a carbon sink. Okay? And why that is the so-called carbonate buffering mechanism. So the CO2 that ends up in the ocean is actually converted to some extent into carbonate ions, and that's used for skeleton formation and shell formation and that sort of stuff. And that's makes the ocean a sink that reduces the CO2 concentrations, and due to the air-sea gas exchange mechanism, the ocean can continue to take more CO2 from the atmosphere. And here are some maps that tell you what happened to the CO2 induced by humans. Where did it end up in the ocean? First of all, there are estimates that the ocean has taken up 25% of the human-induced CO2 emissions. And this is where they end up. They end up essentially in the surface layers of the ocean, and mainly the subtropical gyres. You can see some vertical transects. The top one is the Atlantic, central one is the Indian Ocean, and bottom one is the Pacific Ocean, estimating where, showing you the changes essentially in the CO2 concentrations. And on relatively short time scales, there's just not enough time for the deep ocean effect to play a role. You learned about the thermohaline deep circulation. There's a time scale of several hundred years. Okay, so this is not a big surprise. But however, without this effect of the oceans being a carbon sink, the global warming effect would be much more pronounced, the greenhouse effect. So again, the ocean plays a positive role in all of that. It mitigates the effect of global warming.